get busy with lesson 10.4, page 30 for the 8 general students, and lesson 16.4, page 730 for the 7th accelerated students. Today we're going to continue with exponents and scientific notation by applying what we learned to use definitions of zero and negative exponents to evaluate and simplify expressions. We have two essential questions. How can you evaluate a non-zero number with an exponent of 0, and how can you evaluate a non-zero number with a negative exponent? And of course, I know being a person of character and intelligence, you went to the appropriate pages for your class and you wrote down some notes. So you kind of have an idea, might be a little fuzzy, so let's talk about it. The first thing you learned was that any power where the exponent is equal to 0 is equal to 1. So it doesn't matter what the base is. It can be a number, numerically. It can be a variable, algebraically. So if I have 5 to the 0, that equals 1. If I have 275 to the 0, that equals 1. If I have 4,976 to the 0, that equals 1. Anything to the 0 power equals 1. And if I have a variable, algebraically, to the 0, well, x to the 0 is equal to 1. And b to the 0 equals 1. K to the 0 equals 1. Doesn't matter. Anything to the 0 power equals 1. No matter how that 0 is arrived. We'll talk about that a little bit more when we do a couple of examples to explain exactly why that is true. I just don't want this lesson to take super long. Now let's go to our negative exponents, and you read there that says, hey, no power is simplified if it has a negative exponent. So we've got to spend a little bit of time to get rid of that negative exponent. And it said, well, all you have to do is write the reciprocal of the power and make the exponent positive. So in other words, if I have 5 to the negative 2, and I did the reciprocal and made it positive, I would have 1 over 5 squared. Now, we got to pay attention because this right here, that right there represents the answer if the question says write your answer as a power. Now, if it says simply to simplify, we would have to continue. If we had to simplify without writing as a power, we have to continue and say, well, 1 over 5 squared is 25. And we're still not done because 1 over 25 is you could, I guess, write it as that fraction, but I would want to know, well, what's the equivalent decimal? And of course, 1 divided by 25 would be 0.04. So this is important as well. This is going to really come into play when we have those negative exponents. We completely simplify numerically, we end up with a decimal. And that's going to come into play in a lesson not too long in the future. We'll talk about that more then. Let's talk about having a variable or a number. Let's really quickly. What if we have 1 over 5 to the negative 2? Well, we would do the reciprocal, and that would be just 5 squared, or 25. If we had some variable, x to the negative 2, well, that would be 1 over x squared. We take the reciprocal and make the exponent positive. If I have 1 over x to the negative 2, again, we take the reciprocal, and that becomes x squared. So let's just practice a couple of those. Number 1 says 4 to the 0, and 4 to the 0, that is equal to 1. It has an exponent of 0, it equals 1. We don't have to go any further. Nothing else to do with that. We have x to the 5th times x to the negative 5th. We know when we multiply powers with a common base, we add the exponent. So 5 plus a negative 5, that becomes x to the 0, and we know anything to the 0 power is equal to 1. And then we have number 3, which says negative 5 to the 12th divided by negative 5 to the 12th. And we know when we divide a common base, we again subtract the exponents. So that would give us negative 5 to the 12 minus 12, which becomes negative 5 to the 0, which is 1. So we're going to stop right here. I told you we'd come back. And the reason is I'm going to say, hey, there's a reason why that's 1. It only makes sense because we learned that if you dividing, you subtract the exponents. We subtract the exponents, we got 0, and we said 0 is equal to 1. So let's prove it. Well, hello. We have a negative 5 to the 12th divided by a negative 5 to the 12th. We're dividing by ourselves. When you divide by itself, it equals 1. 5 divided by 5 equals 1. Well, that's 5 to the first power over 5 to the first power. It doesn't matter what they are because 1 minus 1 is 0, so 5 to the 0 is 1. So anytime you divide by yourself, you're going to get 1. Well, dividing by yourself says that when we follow the mathematical properties for exponents and subtract them, we would get 0, giving us 1. All right, let's move on. Y to the negative 6, we have a negative exponent. We can't have negatives. They're not simplified when they're negative, so we take the reciprocal and we're done. Nothing else we can do with that one. X squared times x to the negative 5th. We know we add exponents when we multiply by a common base. So that's 2 plus a negative 5, which gives us x to the negative 3, which we can't have. We've got to have a positive exponent to be simplified. That's 1 over x cubed because we took the reciprocal of that power, x to the negative 3. And we have negative 5 to the 8th over negative 5 to the 12th. We subtract those exponents. So we have negative 5 to the 8 minus 12. That gives us negative 5 to the negative 4, which again becomes the reciprocal to make that exponent positive and fully simplify this expression, 1 over negative 5 to the 4th. And again, ladies and gentlemen, if it says just to simplify, we would have to continue to simplify that power by taking negative 5 to the 4th, writing that fraction, and then creating that decimal. However, we're just going to stop with writing as a power. Number 7, 1 over k to the negative 4th. Again, we got to find the reciprocal. It doesn't matter where that negative is. To make it positive, we take the reciprocal. So this becomes k to the 4th over 1, which is simply k to the 4th. Moving on, some more simplifying, writing again our answers as a power. I should have said that on the first 7. Hello. 8y to the negative 5th. Well, that negative 5 is only attached to the y. So there's nothing we do with the 8. It just stays. And we know we have to take the reciprocal to make that positive. So that would be 8 over y to the 5th. And there's nothing more we can do with that. B to the 0 times b to the negative 9. Following our rule for multiplying with a common base. That's 0 minus 9, which is b to the negative 9, which is 1 over b to the 9th. And number 10, d to the 8th over d to the negative 4th. I want to use my red this time. I'm going to go right here. My coefficients. My coefficients of d. Well, in the top, d to the 8th, what's the coefficient? That's right, it's 1. We're always going to take the coefficients and simplify those first if we can. And 1 over 15, well, that's already simplified. So 1 over 15. The reason I'm writing the 1 is because I want to hold my numerator place. If I don't need it, if I get something else up there and can get rid of the 1, I will. But right now, I'm not. Then I'm going to take a look at d to the 8th divided by d to the negative 4th. And I know that's d to the 8 minus the negative 4. When I can finish off the math, I get d to the 12th over 15. I can get rid of that 1 because d to the 12th takes its place in the numerator. Moving on. Number 11, 2x to the 7th divided by 6x to the 9th. Again, taking those coefficients and simplifying those. That's 1 over 3. And then I have x to the 7th minus 9 because I'm dividing x to the 7th by x to the 9th. And when I continue on, that's x to the negative 2 over 3. Well, I can't have a negative exponent. I got to remember I got to keep going. So then I got to put that 1 back up there because that x squared has to move to the bottom and it had to make that positive. So I end up with 1 over 3x squared. Number 12. I start off with 18y to the negative 3 divided by 12y to the negative 3. So I'm going to simplify that 18 over 12 and get 3 over 2. Well, I have y to the negative 3 minus a negative 3. That gives me 3 over 2, y to the 0, 3y to the 0 over 2. Well, that y to the 0 is 1, so I end up with 3 over 2. All done. Our last example of the day is our real-life application where it says a faucet leaks water at a rate of 5 to the negative 5th liters per second. How many liters of water leak from the faucet in 1 hour? So our final answer needs to be liters per hour. Whatever our answer is, that's what it's got to be. Right now, we have 5 to the negative 5th liters per second. Second. All right, so one of the things I'm going to teach you how to do is how to convert measurements or units. And the first thing I'm going to do is I am going to simplify that 5 to the negative 5. And I'm just going to take that and make that 1 over 5 to the 5th. And I know 1 over 5 to the 5th is 3,000 3,125. So I'm going to rewrite that as 1 over 3,125. So I just converted that into 3,125. All right, so now I've got liters per second. I got to get rid of that. And I know it's 60 seconds per minute. And I know that it's 60 minutes in 1 hour. So I go and I look, and I've got seconds simplifying out, minutes simplifying out, and I'm left with liters per hour. I'm left with liters per hour. Now all I have to do is the numbers. Well, that we got rid of because we turned it into 5 to the 5th, and we got rid of that because we turned it into 3,125. So we have 60 times 60, which is 3,600, over 3,125. Well, I can divide that out, and I can get 1.152 liters per hour. So 1.152 liters per hour is our final answer on how much leaks in 1 hour. Our quick write, ladies and gentlemen, is on the back last page of your notes, so I don't need to leave this up here. You don't need to pause it to write them down. They're just there. Please take a few moments to get those done, and you're done with your notes tonight. We will see you tomorrow. Have a good one.